Hello everyone, welcome to lecture 2 for the chapter Human Eye and the Colorful World. In this lecture, we are going to discuss about the defects of vision. So the first defect of vision that we need to talk about is myopia. So as you can see, myopia is a short word. So it stands for short-sightedness. That is how you can remember it is in an easy way. Short-sightedness or nearsightedness, that refers to myopia. So when I say nearsightedness, it means I can see the nearby objects clearly because I am nearsighted, but I am not able to see the distant objects very clearly. So that is what this defect actually means. A person can see nearby objects clearly, but he is not able to see the distant objects clearly. So as we have discussed in lecture number 1, for a normal human eye, the far point is infinity. But a person who suffers from myopia is not able to see the distant objects clearly. That means his far point is less than infinity. It cannot be greater than infinity because there's nothing which is greater than infinity. So it has to be less than infinity or nearer than infinity. Another important thing to note, for a person with normal vision, the image is formed on the retina. But a person who suffers from myopia, the image will be formed in front of the retina. So these are three main points that actually define what is myopia. Let us understand this better with the help of these diagrams. Now, the first diagram shows you the far point of a myopic eye. So when I say the far point, that means this till this point the person will be able to see clearly, that is point O, because when the object is at this point the image is being formed on the retina. But if you shift the object away from this point, if you take it away, that means now you bring the object to O dash, you can see the change. The image has now shifted to in front of the retina. These rays are now converging somewhere in front of the retina, and that is why we say the person is now suffering from myopia. And because the image is not being formed on the retina, obviously it will become blurred and the person will not be able to see clearly. Now, how to correct this defect? This defect can be corrected by using a concave lens, because a concave lens is a diverging lens. So whatever rays are coming, it will diverge those rays, and finally those rays will now intersect at the retina and the image will be formed on the retina. So now the person, after using a concave lens of a suitable focal length, will be able to see clearly. So this was about myopia. The causes of myopia could be the eyeball has a high, the eye lens has a high converging power, because if the lens is converging the rays a bit too much, they will obviously converge earlier than what they are expected, where they are expected to meet. So the image will be formed in front of the retina. Or sometimes it is a genetic problem that the eyeball is a bit elongated. So though the rays are converging at the normal position, but it's the retina that has shifted back, due to which the image is coming in front of it. So these are two causes, two possible causes of myopia. And we have already discussed the correction. We can correct myopia by using a concave lens of a suitable power. So this was all you need to know about myopia. These diagrams that I have shown you, they are very, very important for your exams. Make sure you practice them well enough, because many times a 5 marks question based on these defects is seen in the question paper. The next defect that we are going to talk about is hypermetropia. So if you compare it with myopia, it's a long word. So it means long sightedness or far sightedness. That means a person who is suffering from hypermetropia is far sighted. He can see the far off objects very clearly, but he cannot see the nearby objects clearly. So hypermetropia is the exact reverse of myopia. So as you can say, the person can see distant objects clearly, but cannot see nearby objects clearly. This is what defines hypermetropia. Further, for a normal eye, that means a person who has normal vision, the near point is 25 centimeters. Now, since a person suffering from myopia cannot see the nearby objects clearly, so obviously his near point will be greater than 25 centimeters. So his near point is now greater than 25 centimeters, or you can say that it is further away from the normal near point of 25 centimeters. Now in this case, the image is going to be formed behind the retina. In case of myopia, the image was in front of the retina, but in case of hypermetropia, the image is formed behind the retina. Let's have a look at these diagrams, very important diagrams again. Now, if I refer to the normal near point of a hypermetropic eye, this is the near point. We represent it using the letter N. That means an object kept at this point or beyond this will be clearly visible to the person because the image is being formed on the retina. But if the image is brought closer to the eye, now in this case, because the person is not able to see the nearby objects clearly, so we are bringing the object closer to the eye, you can see the image goes behind the retina. So how to correct this? We use a convex lens, which is a converging lens. So it is going to converge the beam of light, and that causes the image to be formed on the retina. So even if the if object is quite close to the eye, if we use a convex lens of suitable power, the image will be formed now on the retina. So what could be the possible causes of hypermetropia? It could be the low converging power of the eye lens. That is, the eye lens is not bending the light enough, and due to which the light rays are intersecting behind the retina. Or if it is genetic, then the eyeball is small in size, due to which, in spite of the normal curvature of the cornea and normal focal length of the eye lens, the image is going behind the retina. It is actually the retina which has moved ahead because of the small size of the eyeball. We have already discussed the correction, that it can be corrected by using a convex lens of a suitable power. The third defect that we are going to talk about is presbyopia. It's also known as old age hypermetropia. It is something which almost everyone suffers at some stage of their life, and it generally happens at an old age because a person cannot read comfortably and clearly without the use of spectacles. You must have seen elders at home using reading glasses. Normally, you never see children using reading glasses. It always happens at an later stage of the life. So this is caused because the ciliary muscles with age, they lose their flexibility and they become weak, due to which the lens is not able to adjust its focal length to focus on the nearby objects. That is what causes presbyopia, though it is just similar to hypermetropia, but since it is caused in old age due to gradual weakening of the ciliary muscles here, the name presbyopia has been given. So the correction also remains the same. It can be corrected by using a convex lens of a suitable power. Now, at times what happens is that a person may suffer from both myopia and hypermetropia. There is no name given to this defect. Often I have seen some people confusing it with presbyopia, but no, we don't call it presbyopia. Please keep that in your mind. It doesn't have any name. It is a combination of both myopia and hypermetropia, and it can be corrected by using a bifocal lens. What is the meaning of bifocal lens? Means in one glass there are two lenses. The upper half is a concave lens for distant vision, because when we look at a distant object we tend to see straight, and the lower half is a convex lens for your near vision, because when you're reading something you always look down, right? So bifocal lens means a lens which has two lenses. The upper half is concave for distant vision and the lower half is convex for nearby vision. Another very common defect of vision is cataract. Now this again happens in old age. This is not due to reducing flexibility or something. It is because with age, the lens of our eye becomes hazy. It becomes clouded due to deposition of certain sugars or proteins on it. And because of that, obviously, if an opaque layer comes in front of the lens, how will you see? So the treatment for this is surgery. If it is at an early stage, the medicines are enough to remove that deposition. Otherwise, the lens has to be replaced. So that is known as a cataract surgery, a very common surgery performed everywhere these days. Now, you may be asked numericals on these defects of vision. Though the formula remains the same, which you have studied in the first chapter, light, reflection and refraction, will be using the lens formula and the formula for power here. But there are certain points that you need to understand. You'll find these two numericals in your NCERT textbook, the ones that I'm going to discuss in this video right now. So let's have a look at these numericals. The question says the far point of a myopic person is 80 centimeters in front of the eye. So always remember, the far point is 80 centimeters in front of the eye, and the nature and power of the lens that is required to correct the problem has to be identified. So first of all, we have to identify what is V, what is U. Now, since person is short-sightedness, it's myopia, person is short-sighted, he cannot see the distant objects clearly, and you want him to see the objects placed at infinity clearly. So obviously U will be infinity, means U is that part which the object is not able, which the person is not able to see, and we want him to see. So 80 centimeters that is given in the question will be V, and it's going to be negative. Both the terms here are going to be negative. You have to find out the power. So for power, you first need to find out F. Now, you know the lens formula is 1 upon V minus 1 upon U is equal to 1 upon F. So if we use this formula and we substitute the values, what do we get? It's 1 upon minus 80 minus 1 upon minus infinity. So anything divided by infinity is obviously going to have 0.00000 something very minimal, a very small value, so we can ignore that. So ultimately you get your focal length equal to a negative 80 centimeters. Now this is the focal length that you've got. Once you know the focal length, you can very easily calculate the power. What is power? Power is 1 upon focal length, but you have to be careful. The value has to be in meters. So what do? It's 1 upon minus 80 centimeters, and we have to divide it by 100 to convert it to meters. So I am multiplying it by 100 here since 80 is in the denominator. So if I divide it by 100, it goes to the numerator. And the power that you will get is minus 1.25 diopter. So the negative sign here tells you the nature of the lens. It is going to be a concave lens. There's one more question which you'll find in your NCERT exercise from the same chapter. Now this one is based on hypermetropia. The near point of a hypermetropic eye is 1 meter. Obviously, since you want the person to have a clear near vision, your U would be minus 25 centimeter, because the near point is minus 25. And the value given to you in the question, that is V, is 1 meter. So minus 1 meter means negative 100 centimeters. And you can find out F here. Again, we will use the lens formula. 1 upon F is equal to 1 upon V minus 1 upon U. Substitute the values here. It becomes 1 upon minus 100 minus 1 upon minus 25. So when you simplify this for F, you will get 1 upon F is equal to 3 upon 100 positive, and your focal length would be 100 upon 3. So I'll just erase this sign here because it's not required here. So this is the focal length that you get. Now you have to find out the power, because you have not been asked the focal length, so there's no need to convert it to decimals. We straight away use the formula for power, that is 1 upon focal length in meters, that is 1 upon 100 upon 3 times 100, because this was in centimeters. Now we have converted to meters, and that gives your power as 3 diopters. That positive power tells you that the nature of your lens is going to be a convex lens. So that is how you solve these questions. I hope you have understood all the defects of vision and the numericals based on them very clearly. In case not, go through the video once again and see you in the next video with more concepts from the same chapter.